A shaft carries 4 masses A, B, C and D of magnitude 200 kg, 300 kg, 400 kg and 200 kg respectively, revolving at a radius of 80 mm, 70 mm, 60 mm and 80 mm in a plane measured from A at 300 mm, 400 mm, 700 mm. Let us take 4 masses A, B, C, D. A, B, C and D. Here some conditions are given. I mean the distance between A and B, A and C, A and D are given. Here the B are placed around 300 mm from A. So distance from A to B 0.3 meter. Then measured from A at 400 mm, that is C. So C, distance between A and C 400 mm, 0.4 meter, which means this distance 0.1 meter. Then A to D 700 mm, that is 7.7 meter, which means the remaining distance 0.3 meter. So these are all the given data. Then the angles between crank measured from anti-clockwise are A to B 45 degree. We can take A as a reference plane from A to B 45 degree. So this is 45 degree. I can take this diagram as linear position. I can take this diagram as angular position. Okay, then B to C 70 degree, this distance 70 degree. Then C to D 120 degree, so this is 120. So these are all the given data for this problem. Apart from that, the balancing masses are to be placed in a plane X and Y. So there is a separate plane for X and Y. The distance between the plane A and X is 100 mm. So A to X 100 mm. That's why I'm taking X as a plane between A to B. Then the distance between X and Y is, this is X, this is Y. So distance between X to Y, distance between X to Y 0.4 meter. So that is a condition. And between Y and D is 200 mm here. So this distance 0.2 meter. So these are all the given data. The balancing masses revolve at a radius. So radius of the balancing masses, I mean or X or Y, 100 mm. I can take it as 0.01 meter. This is 0.01 meter. Here our aim is to find the magnitude. We need to find out mx theta x, my theta y. So these are all the parameters we need to find out for this problem. So with this detail, now we will move on to linear, angular position, force polygon and couple polygon for this diagram, for this application. Next we need to draw a table from the given data. First column plane, second column mass, third column radius. Then using mass and radius we have to calculate centrifugal force and distance. Then finally we will calculate couple. First we will mark the order of the plane. Go back to your problem. See here, in this linear diagram we have a order for plane. It starts with A, X, B, C, Y, and it ends with D. So this is the order of plane. Then the magnitude of masses A, B, C and D are 200 kg, 300 kg, 400 kg and 200 kg. Then the corresponding radius 80 mm, 70 mm, 60 mm, 80 mm. Then the balancing masses, that is X, Y, the radius are 100 mm, 0.101 meter. So we will take all those data and mark it on table. Here the first column, plane, the order of the plane A, X, B, Y, C, Y and D. Then the corresponding masses 200 kg, 300 kg, 400 kg and 200 kg respectively. Here X and Y are unknown, so these are the values we need to find out, balancing masses. So we will take it as mx and my. Then the corresponding radius 80 mm, radius of mass A 80 mm. Then B, C, D are 0.07, 0.06, 0.08 meter. Then the radius of balancing mass 100 mm, that is given in the problem, so we will take it as 0.1 meter. Now we have to calculate centrifugal force. So centrifugal force is nothing but multiplication of mass and radius, mr. Just multiply mass and radius, you will get centrifugal force. 200 multiplied by 0.08, 16. 300 multiplied by 0.07, 21. 400 multiplied by 0.06, 24. 200 multiplied by 0.08, 16. So these are all centrifugal forces. Next we need to calculate distance. Before we calculate distance, we need to choose a reference plane. Here I am going to take X as a reference plane. Let me explain later why I choose X as a reference plane, but as of now you consider X as a reference plane. Then calculate distance. Here distance reference distance between X and corresponding plane. For this corresponding plane A, so we need to find the distance between X and A. Go back to the linear diagram. Here this is X and this is A, so we are using the leftward direction. So leftward means minus, rightward means positive. Again the distance 0.1 meter. So we are moving from X to A, so I am going to take that value as minus 0.1. That's why here I used minus 0.1. Then distance between X and again reference plane. Here the corresponding plane X. Distance between X and X 0. The next one, distance between X and corresponding plane B. So X to B 200 mm. Just go back to the diagram. A to B 0.3 meter. This is 0.1 meter. Then the remaining distance 0.2 meter. So here I can mark 0.2 meter. Similarly find distance between X and corresponding plane. Here X and C 0.3 meter. Then X and Y 0.4 meter. X and D corresponding plane D 0.6 meter. Now I can find couple. Couple is nothing but multiplication of force, centrifugal force with the distance. Just multiply these two columns, you will get couple. 16 multiplied by 0.1 minus 1.6, then this is 0. Then 21 multiplied by 0.2, 4.2. Then the remaining parameters are 7.2, 0.04 my, 9.6. Now I will tell you why I chose X as a reference plane. Our ultimate aim is, see here I have two unknown, but this is one equation. That column represent one equation. So when I move from force to couple, I need to reduce this two unknown to one unknown. So how can I reduce two unknown to one unknown? I have to make it either this value or this value to 0. So how can I bring this value to 0? By taking x as a reference plane. If I take x as a reference plane, this will be 0, then the corresponding multiplication will be 0. See here, yeah, we have only one unknown. Suppose if I take a as a reference plane, what will happen? Again here I will get two unknown. There should be some multiplication of mx and this is my. Then it is very difficult to solve this problem. So our ultimate aim is we have to choose a reference plane in such a way that the number of unknown on force column or couple column should be 1. Any one. Here we have two unknown, whereas here I have only one unknown. So we have to choose the reference plane in such a way that will reduce the number of unknown from 2 to 1. So this is how you have to choose the reference plane. So now we will draw the linear diagram, angular diagram, force polygon and couple polygon diagram. We already have linear diagram. So this is a linear diagram and this is an angular diagram. So let me copy these two diagram here. So this is a linear diagram and here I have an angular diagram. Now I have to draw either force polygon or couple polygon. Now go back to your table. Here we have only one unknown. So first I need to draw couple polygon. Whereas here I have two unknown, it's very difficult to find all the two values. So I will start with couple polygon. First I'm going to draw this parameter. First draw 1.6 corresponding plane A, then draw 4.2 corresponding plane B, then draw 7.2 corresponding plane C, then draw 9.6 corresponding plane 9.6. So first I'm going to draw the first value 1.6. So this is the direction. Take a point. So this is the starting point. This is the starting point. This is the direction, but we have minus 1.6. So I'm going to use negative direction. So this is plus 1.6. So I'm using minus 1.6, opposite direction. Next I'm going to move B. The B value 4.2. If you have a doubt, please go back to the diagram. 4.2 corresponding plane B, then 7.2 corresponding plane C. Now first move A in the opposite direction because of the minus sign, then move B value positive, so we can keep as it is 4.2. Take 1.6 as 1.6 centimeter, 4.2 as 4.2 centimeter. So this is the direction A, this is O and this is B. Next move C. So C value 7.2. Refer the table. Corresponding plane C, the value of distance 7.2, I mean couple. So mark 7.2. Just move this line from angular diagram to couple polygon. The name of the diagram, couple polygon. Then finally move D. So D value 9.6. So this is 9.6 centimeter. Take 9.6 as 9.6 centimeter. Now you see the diagram. This is an open polygon. This is not a closed polygon. But to satisfy the static balancing condition, this should be a closed polygon. So now connect point D and O. So this is point O. When you connect this point, you will get a distance like this. So this is OD. So measure OD. So this is a direction. It will move like this and finally it will come out like this. So now measure OD, then move OD from couple polygon to angular diagram. If you see the angular diagram, so this is how it will be placed, right? So this is what we have earlier. Now move this line. So this is our Y, point Y. Measure this angle. So measure this magnitude. Before that you measure the magnitude, measure this line. This is a magnitude, and move this line. Move this line here, you will get an angle. If you measure this line, so this is the remaining parameter 0.04 my. Go back to your diagram. So this is a 0.04 my, the missing parameter. So now I'm going to draw that parameter. So 0.04 my equal to, when you measure this, you will get 7.3 centimeter. I can take 7.3 centimeter as 7.3 kg meter square. So we can take as it is. Now rearrange the term. My equal to 7.3 divided by 0.04, you will get my equal to 182.5 kg. So this is the value of mass. Similarly, you can measure the angle. When you measure this angle, you will get 12 degree. So that is an angle of my. And we will place y, mass my, at this point. Here my equal to 182.5 kg. Then the corresponding angle between A and Y is 12 degree. So this is how we can find the balancing mass on plane Y. The mass of the plane, on the plane 182.5 kg. Then the plane makes an angle of 12 degree with respect to plane A. Now I'm going to draw the force polygon. For that, we know the value of my, 182.5 kg. So this is what we have calculated from couple polygon. Now I can multiply 0.1 with my value. This should be 18.25. So now I have a value of 16, 21, 24, 18.25 and 16. It's very difficult to mark these points in centimeter on ordinary sheet. So we will take all these parameters as divided by 4. So this should be 4, this should be 3 point something, this is 6, again this is 4 point something, again this will be divided as 5 point something. So let me mark these parameters on sheet. 4, 3, 6, 3 point something, 5 point something and 4 point something. For that we will, so now I'm going to draw force polygon. First mark line A value 16, then the corresponding reduced scale factor 4. So mark A as a 4 centimeter. Direction as it is. Since it is positive value, we will take the direction as it is. Then I am going to move B at the end of line A. B value 21. So 21 divided by 4, 5 point something. So we will mark that 5 point something value here. So this is B. Next, B to C. We will mark this parameter 24. So 24 divided by 4, 6. So we will mark point C here. Direction as it is. Next, D. So D direction 16 divided by 4, so we will mark 4 here. Then next, this line, this is 18.2 my, this is 18.2 divided by 4 point something, so this is 4 point some value, 4 plus. Okay, it will move up to this point, it won't cut this line, so it will be somewhere here. Now there is an open end, so this is an open end. Now connect this line, so connect this line, measure the point, this is D and this is Y. Now you connect this point, so this line represent 0.1 mx. Now move this line here, so this is A and this is Y, B, C, D. Now move this line to the top of the diagram, so it will connect at this point. So this is a starting point, so it will move like this. So this is point X. Now you measure distance. Actually the distance are placed like this. Let A, this is X, B, C and D. You measure this distance. When you measure this distance, you will get 145 degree. We have to measure the distance not along this direction, along this direction. When you measure along this direction, it will be 145 degree. That's why theta y equal to 145 degree. Now what is the magnitude? For that, what I'm going to do is to calculate that magnitude, you just measure this distance. When you measure that distance, you will get 0.1 mx, this distance. When you measure this distance, you will get 8.87. Then earlier we have used a scale factor of 1 by 4. So to get the original value, we need to multiply that with 4. So 8.87 centimeter multiplied by 4, 35.5 kg meter. So that is the value of mx. From that, mx equal to 355 kg. So this is the value of mx. Mx equal to 355 kg. Then x placed around 145 degree from A. The distance, angular distance between A and B, A to X, is around 145 degree. So this is the answer for balancing mass on X and the corresponding angular displacement. So this is how you have to solve a problem on balancing of rotating mass. The final answer will be the mass on My and Mx. Here it is 182.5 kg, whereas here 355 kg. Then the corresponding angle theta y equal to 12 degree. So this is 12 degree. This angle 12 degree, whereas here for theta x the angle is 145 degree. So that you have to measure from these 2 points. So this is how you can find the balancing masses on plane X and Y. Don't forget to post your questions in the comment box. You can also mention the topics which you expect from my channel. Subscribe my channel and like my video to support my video lecture.